Hello, and welcome to another episode of Miss Faust Does Algebra 2. This is lesson 1.1.4, and what we're going to start looking at today is inverse functions and how you know it's an inverse function. So this continues with the work we've been doing with functions. We've talked about function vocabulary, how we describe functions, and now we're going to look at inverse functions. And if you think about the word inverse, inverse usually means like the opposite of something or to undo something. So that's really what an inverse function is doing too. I'm going to start just by showing you a couple graphs. If you want to pause now and get your notes set up, you can. But the next few minutes, I'm not going to ask you to write all this down. I just want you to see the examples so you start to get a visual in your head of what inverse functions look like. So let me just drag this little graph over. And what I want you to focus on is these points right here. So these points, it's just a collection of points, but that collection of points makes up a function. Often we have lines. This time we're just going to look at a set of points. So what you can see here, I plotted all the points and then I plotted this dotted line. And the idea behind an inverse function is that it switches x's and y's. So if we start with this function that's the set of red points, what we're going to do is we're going to look at the inverse of each of those points. So if I start by looking at this point, -1, 4, for example. When I talk about the inverse, I'm going to just switch the x and the y, and the inverse of that first point would be at 4, -1. So you can see that comes down over here, and we've got the inverse of the first point. The next point I'm going to look at is this 1, 2. So when I think about 1 and 2, if I'm going to find the inverse, I'm going to switch the coordinates, and my new point's going to be here at 2, 1. So it just kind of flips it over the line, and that's where our new point is. Next one, if we talk about 2, 3, when we want the inverse, we switch the 2 and the 3. So our new point's going to be at 3, 2, right there. And finally, we have this point at 4, 1. We want the inverse again, so we switch the x and y. So our new point's going to be at 1, 4, which should be right there. And let us just see, magic, there it is. So it's a little bit hard to see when you have them all at once, but if you look closely, you can find the inverse of each point. So -1, 4, 4, -1, 1, 4, 4, 1. And that's the inverse. So the blue points here are representing the inverse function. As I said, usually we look at functions that are lines, but I just wanted you to see that this works whether or not you have lines. So let me just get rid of these points. Bear with me for a moment. There we go. So now I left this line y equals x in because the inverse always flips over that line. So if we started with the line y equals 2x plus 1, so y-intercept of 1, slope of 2, you heard the bell again, just lunch ending. So 2x plus 1, so up 2 over 1, up 2 over 1, starting at 1. When we want the inverse of that, basically we're going to look and flip this line over this dotted line. So try to take a minute and think about what that'll look like in your head first, and then I'm going to make it magically appear for you. So when I look at it, I think, okay, this point, if the x and y switch, is going to go down here. This point's going to stay in exactly the same spot. So that's going to help me visualize the inverse function. There it is. So the inverse function here, you can see if you were to fold along this dotted line, the red lines and the blue lines would line up. That's a lot of lines, but you get the idea, I hope. So along the dotted line, and then the red function and the blue function are inverses because they're reflected over that line. So let's take a little time now and just formalize some of that and start to look at how we actually find an inverse function. Because it's great when the computer makes it magically appear, but that's not what's going to happen in real life. So some notes. The inverse of a function gives you back the original inputs. So basically, if your function takes you from x to y, x to y, then the inverse takes those y's and takes you back to x again. If you think about that function machine you did in elementary school where you drop something in on one side and it goes and it comes out, the inverse is like you're going back the other way. So the important thing is that the x and y values switch positions in an inverse function. And that works whether you have a bunch of points, it works if you have a table, it works if you have a graph. It just shows up slightly differently in all of them. Now let's look at finding the inverse of a function. So to find, 1i, the inverse of a function. Step 1 is to rewrite your f of x as a y. And that's just, it's not like a necessary step, it just makes it easier because then you're going to solve for y. It's easier to solve for y than it is going to be to try and solve for f of x. Step 2, switch. Remember the big idea behind inverses is we switch x and y. So that's exactly what we do, switch x and y. Step 3, now you want to solve for y again, because when you switch x and y, you'll get x equals something. Well, to get it back into function form, we need a y. And then the answer is f inverse of x, or that's just another way of saying the inverse function. So this little f with a -1, that notation stands for the inverse of a function. And we're going to see that a lot over and over. You'll get used to it as the year goes on. So let's do an example. Example 1. So in example 1, we're going to let f of x equal -2x plus 5. So if we want the inverse of that function, let me just adjust here slightly. There we go. F of x equals 2x plus 5. So we start by replacing this f of x with y, just so that it's a little bit easier to do the rest of it. So step 1, we say y equals -2x plus 5. Step 2, we switch x and y. So we just literally take the x and the y, and we put them in opposite positions. So we say x equals -2y plus 5. And now we need to get y by itself, because notice y is now embedded over here in the problem. So what we're going to do from here, we're going to use our good old-fashioned solving skills from Algebra 1. So first we would subtract 5 on both sides. 5, and we get x minus 5 equals -2y. Then, if I can make it all show up at once, this is close. Divide both sides by -2. So let me just do this. So we get x minus 5 over -2 equals y. Because we're going to want to graph these, we want to make this a little cleaner. So x over -2 is the same as -x over 2, and -5 divided by -2 is really just positive 2.5. And what I'm going to do here is I'm going to replace the y with f inverse of x. So my inverse function, or my answer in this problem, and that -x over 2 really means -1 over 2 times x. Again, I do that because I'm going to want to graph these, plus 2.5. Okay, so you can see then we have our two functions. I'm going to bring the graph over again so we can look at this and make sure that they're really inverses. So I'm just going to come here. I'm going to change this function to -2x plus 5. And the second one we had was -1/2 x plus 2.5. And again, you don't need to draw the graph or anything. I just want you to see that when we do that, it reflects over this line. The red one was the original function. The blue one is the inverse function. So just a good way to check your work and see that you have the right inverse function. So let's do another example or two of that. Just get some more space here. Ooh, that is not a straight line, but that is okay because sometimes we don't make straight lines. And that's not the end of the world. Okay, sorry, I'm telling random stories. You'll get used to it. Okay, so let's try another example. Switch to an example color, example 2. So in example 2, we are going to start with f of x equals, let's do 3/4 x minus 1. So again, to start, we replace our f of x with y. So we have y equals 3/4 x minus 1. We need to switch our x and our y. So when we switch our x and our y, we get x equals 3/4 y minus 1. Now we need to solve for y. So we add 1 on both sides. X plus 1 equals 3/4 y. At this point we always get a little stuck because we don't remember a lot of Algebra 1, but to get rid of a fraction like that, we multiply both sides by the reciprocal. So I'm going to multiply the left side by 4 over 3, excuse me, 4 over 3. Another mistake in this one. Anyone keeping track? I hope not. Multiply the right side by 4 over 3. And then what happens, and I'm purposely using a yellow pen because I don't want it to show up too much, the 4's here cancel and the 3's cancel. And on the other side, we use the distributive property and we get 4 over 3x plus 4 over 3 times 1 is 4 over 3. So all of that is equal to y, which means our inverse function is 4 over 3x plus 4 over 3. And again, at this point, we could go to a graph. We could graph both of those functions, and we would see that they're reflected over that dotted line. Just want to show you one more way to see if something is an inverse function, in case you don't always have a graph with you or you want another way to check it. So let's just do a little dotted line there. Showing functions are inverses. So one way to show functions are inverses are to graph them. And if you have a graphing calculator, you can do it there. I will show you how to use Desmos in class next time. That's the graphing software that I use on the computer. That way you can always check your answers that way. The other way is you can check it algebraically. And in order to check algebraically, what's going to happen is you're going to have two functions. You're going to have f of x and you're going to have g of x. And you're trying to determine if those are inverses. So f of x is equal to something, g of x is equal to something else. What you want to do is you want to pick a number. You want to plug that number into f of x. And I'll show you how to do this. Just got to get the words out first. So we plug that into f of x. You take the answer you get and plug it into g of x. If you have an inverse function, then when you plug into g of x, you will get back the original number. So say you pick 3. Plug 3 into f of x, do the algebra, see what you get. You get 7. So you take 7, you plug it into g of x. You do the algebra again. Remember we started with 3. If we get a 3 back in g of x, we have an inverse. If we don't get a 3 back, we don't. So let's take a look at examples of that. So this would be example 3. Our f of x equals 1/2 x minus 3, and g of x equals 2x plus 6. Inverses. Okay, so the algebraic way to do that, and that's what this is all about. We can graph them. You could do the calculations and actually calculate the inverse of f of x if you want and see if it's the same function. But what I'm trying to show you now is how we do it algebraically. So we're going to start with some number for x, and I'm just going to say x equals 4. You don't like 4? You could pick a different one. F of 4 is 1/2 times 4 minus 3. Well, 1/2 times 4 is 2. 2 minus 3 is -1. Now I take that -1, the answer that I got, and I plug it into g. So I do g of -1. 2 times -1 plus 6. 2 times -1 is -2. -2 plus 6 is 4. Ding, 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 ding. We have a winner. The answer that we got, the 4, is the same as the x we started with. So, yes, they are inverses. Inverse functions, if we want to be precise. If we'd gotten a different number back here, if we'd gotten something like 17, then we know they're not inverses. I think that brings us to the end of today's lesson. When we come back to class, we'll look more at graphs. We'll do some more practice algebraically, but hopefully you've got the big idea of how to find inverse functions. Thank you very much, and have a wonderful day.